Okay, this is section 2.2, still talking about parabolas. We're talking about attributes of parabolas. This one won't be quite as intense as last one was. Okay. I think we are going to just jump right into example 1. We're going to talk about some new vocabulary having to do with parabolas when you see it in the graph, and some new things you're going to have to add to the graph to have them be complete. So example 1 says we're dealing with the function f of x equals -2 and then x plus 3 squared plus 4. Okay, in this form of the parabola, it should be really easy to read it for transformations. Let's see. In this form right here, we've got the squared part right here, and inside the squared part, we have plus 3. So we know that from the parent anyway, this thing's going to go left 3. We know it's going to go up 4 because that's on the outside. We know it's going to have a vertical stretch of 2. And a negative sign right there is also going to make it open down. Or actually, that's what's going to happen, but what we're supposed to write is a reflection in the x. If we're going to list transformations appropriately, we're going to say reflect in x-axis. That's how we write it. This is what's going to happen. It's going to open down. Okay, so what we've got to do is get our chalk located left 3 and up 4 from the origin. By the way, that thing is the vertex, because the vertex of the parent is right here, 0, 0. So we've just moved the vertex to there. And we know the thing's going to open down. So what you're going to have to do today is actually, when you graph it, you're going to have to locate or identify the vertex. So you put a V, and you put -3, 4. So you're going to have to identify the vertex. And then the rest of this tells us how to count it. We're going to count down, and every odd number is going to be doubled. Every time we go out 1, we're going to go down double the next odd number. So we're going to go out 1, down 2, out 1, not down 3, but 6. And the next one would be and we go out 1, not down 5, because that would be the next odd number, but 10. Now you don't have to plot this many points. I want you to remember how you do the doubling the odd number thing. This many points would be plenty. I'll go ahead and draw this one over here since I drew it for the other one. And this would be a picture of your parabola. That would be the graph of it if they ask you to graph it, and they will be asking you to graph a lot. Okay? It doesn't have to be perfect. You can see over here I had to kind of fudge to get to the next one, but that's good enough. The other thing that you're going to have to be able to identify is called the axis of symmetry. We've talked about this before, but you actually have to draw it now. Put it on here. It's a dotted line because it's not actually part of the graph, but we're going to draw it. And in order to draw it, I'm going to have to move my location, my writing of the vertex. So I'm going to move it over here. Vertex is -3, 4. And this is the axis of symmetry. When you draw it, you can draw all of these with graphite. You don't have to do color. But when you draw the axis, you should dot it. And somewhere near the axis, or with an arrow leading away from it, something like this, you write the word axis. You have to write axis. And you have to write it as an equation. It'll always be a vertical axis, and if you'll remember from your experience in Algebra 1 and in geometry, vertical lines are always written x equals something. What's the something? Well, the something is how far it out is from the origin. It's going to be 1, 2, 3, back 3, so it's -3. Besides that, you think about this for a minute. All parabolas that open down or open up, the axis of symmetry, which goes through the vertex right here, that axis has got to be just as far out as the vertex. So these guys will always match because they're both out the same distance. The vertex is out -3, the axis is out -3 through that same x coordinate. Okay. So let's look at what they asked us to do. It says graph this, label the vertex and the axis of symmetry. Voila, this is the answer. This helped us get there, but this is the answer because they asked us to graph it, and that's all they want for the answer. But it has to have this, the vertex labeled, and the axis labeled. Okay? Make sure you draw the axis with a dotted line. Okay? Now, let's take a look at example 2 because this is going to be way different with what we have to do in this preparation right here. It's going to be a lot different because it's presented to us differently. This one, the way the example 1 was given to us, was really easy to read. For a left 3, up 4, vertical stretch of 2, reflected over the x-axis. All that stuff was very easy to tell in this form. By the way, this form of an equation, or quadratic, is called vertex form. This is it in general. Vertex form, in a general way, not specific to this one, vertex form is of the form a times x minus h squared plus k. In this case, 4 was k, that was the up move. H was 3, that was the, well, actually negative 3, that was the down move. And A was negative 2. When A is negative, it opens downward. When A is positive, it opens upward. When A is greater than 1, it's a vertical stretch of the parent. When A is between 0 and 1, it's a vertical shrink. There's a huge amount of information in that A right there. Well, not all parabolas are given to you in vertex form. It's really nice if it is, because you can read transformations fairly easily. What we're going to talk about now is a parabola given to us in general form, standard form, and it is ax squared plus bx plus c. This is standard or general. Depends on the book, but ours is saying standard form. This is the form that you're used to seeing a quadratic in when you want to apply the quadratic formula, for example. Or if it looks like it's factorable, when you draw those factors down there, try to find the zeros of it. Quadratic formula, which is, if you'll remember, negative b plus or minus the square root of b squared minus 4 times ac all over twice a. In this form, you can clearly identify a, b, and c in order to use the quadratic formula. But it is not readable for transformations and where the graph's going to show up. So you have to learn about how to handle this. Here's the deal. In standard form, the vertex, you can't read this for the vertex. You can't tell where the vertex is when it's like this. But you can find it. The vertex is going to be negative b over 2a. That comes from the quadratic formula, by the way, but you don't need to know that. It's negative is the opposite of b over twice a. That's the x-coordinate of the vertex, just like the x-coordinate of this one was negative 3 when we read it. You can't read that from this. It's in a funny form. So to figure it out, you have to take the opposite of this number and put it over twice this number. And that's the x-coordinate of the vertex. The y-coordinate of the vertex is what you get when you plug this in. It'll make more sense to you when you see an example. But the vertex in this standard form here, in a general way, is you take the opposite of this over twice this, it's a number. You take that number and you plug it in for this x, you square it, take it times a, and this x times b, and then you add c, and whatever kicks out of that, that's your y-coordinate. Takes a lot of work, but your calculator's good at working it out. Then, here's the cool part. This number right here in standard form and this number right here in vertex form are exactly the same. So this A, even though we couldn't read where the vertex was, this A still tells us whether it's going to open up or down and whether it's going to be fat or skinny depending on the size of the number. So we know that it will either open, if A is positive, it opens upward. If A is negative, it opens downward. This is a way of writing negative and positive rather than the words neg and pos. When A is greater than 0, it means it's positive. It means you can expect the parabola to open upward. When A is less than 0, meaning negative, you can expect it to open downward. So that sign on A tells you whether it's going to open up or down. That's important information. And again, as you've seen before, if A, this very A right here, serves the same purpose as that one. If A is greater than 1, it will be a vertical stretch. In other words, skinnier than the parent. If A, the size of A is between, try that again. If A is trapped in between 0 and 1, the size of it, not the sign, we've already dealt with the sign right there, right here. But if the size of A is between 0 and 1, then it is a vertical shrink, and you can expect it to be fatter. Okay, so let's see if we can figure out how to graph an equation that's offered to us in this form, standard form. You may want to refer back to this. You may want to take a picture of what you're looking on your screen right now so that you can refer back to it. But I'm going to erase it because I don't have that much space to lecture to you on. So I'm going to get rid of this graph while you're writing things down, or you can pause it and write it because you're going to need it. And I'm going to erase all of this so that we can do a problem. So make sure you're referencing back to what you had before. Hopefully you wrote that down. So here's what example 2 does. Example says, let f of x be 3x squared minus 6x plus 1. Okay. Now, remember to find our vertex, the place where we're going to start to graph this thing. We need to clearly be able to identify and understand what A, B, and C are. First of all, A is 3, B is negative 6, C is 1. The x-coordinate of the vertex is negative b over 2a. That's what I'm going to find first. And I highly recommend that every time you're looking for this, you write that down. This formula, every time. So then you'll memorize it as you go through. You don't have to work at it to memorize it. And so we say negative b over 2a equals. When I say the negative b, I don't mean a negative number. I mean the opposite of b. So I'm going to put a 6 here. And then a is 3, and I'm going to double that. That's also 6. Well, 6 over 6 is 1. Here's what I know. I know that the vertex of this thing, vertex, has an x-coordinate of 1. That's what I found out right here. Now I want to plug that in. In other words, I want to find f of 1. Remember what that means? It means to make all of your x's turn into a 1 in the problem up here. So this one's going to be 3 times, in parentheses, 1 squared. Why do I do that? I know you know that 1 squared is 1, because I want to show you what happens when this thing is 7/8 or negative 13/6 or something crazy and weird like that. What you do is you write the 3 and you replace the x with whatever's sitting here, whatever you got for the x-coordinate. Close the parenthesis and square it. Minus times 1 in parentheses plus 1. And 1 is a super easy number to handle. I recognize that. And the author is giving you one this simple right now so that you're not struggling with the arithmetic. But these numbers that are the x-coordinate, when you do this fraction right here, they can be really ugly. So I'm suggesting that you do this. We'll do another ugly one here in just a minute. And then either do the arithmetic yourself or make your calculator do it. Let's say, for example, this thing right here was 13/6. You probably don't want to do the arithmetic by squaring 13/6 and then multiplying that result times 3 and then taking negative 6 times 13/6 and doing the arithmetic on those two and then adding 1. That's really hard to do. Nobody does the arithmetic very well because fractions are hard. So if it were ugly like that, this is what I'm recommending that you do. Once you get to this point right here, put it in your calculator and make it do the calculating. So you would type exactly what you see, which is 3, parenthesis, 1, close it, squared, minus, the minus sign, not negative sign, minus 6, parenthesis, 1, close it, plus 1, and then hit enter, and it will tell you the y value. In this case, it was really easy arithmetic because 1's a very nice number. When it's not, you can make your calculator do it. You can even convert it to a fraction, as you remember, which is math enter, enter. So I get a negative 2 when I plug that in. So f of 1 turned out to be negative 2. So I know now that my vertex, I'm going to write it again, my vertex is 1, negative 2. And that's the most difficult part of doing this kind of problem from standard form, is finding the vertex. Because after that, This number right here, the A value, tells you the rest. Since A is positive, upward. Since it's 3, it will be a vertical stretch, or in other words, skinnier by 3. If you know these three things, if you know where the parabola is, which is the vertex, which direction it opens, and how it's going to be counted, you can graph it. But you got to find this, and this part right here is the most intensive because it's new. Negative b over 2a gives you the x. You plug it in for this x here and this x here and kick out a value using your calculator. That's the y coordinate. That tells you where to start without having to read it from here. You can't read it. You have to figure it. So now that I know and summarize this information right here, to produce the graph, we follow those instructions. We start at 1, negative 2. It starts right here. And then I get into my mind, I'm going to open it upwards. It's going to have a vertical stretch of 3. So I'm going to go out 1, up not 1, because that would be the first odd number, but 3. From there, I'm going to go out 1, not up 3. That would be the next odd number, but 3 times that, or 9. And that will be enough, because I'm not tall enough to count the rest. Jump across your axis, get some other side points over here like this, and draw your graph. However, remember in this section we have to do some things to this before it's complete. We have to identify the vertex, which we figured over here. 1, negative 2, you have to write it right on the graph. You also have to draw and label an axis of symmetry. The axis of symmetry goes right through the axis, and it is axis colon x equals 1, because it's out 1 just like the vertex. So that one's done. So let's see if we followed all the instructions. It says graph this thing, label the vertex as an axis of symmetry. That's what we did. But finding the vertex took a considerable amount of math and memorizing of formulas. You can do it. Moving on. The next idea, which is found on page 58, if you're following along at all, is an idea of a maximum or a minimum. So I want to have just a generalized discussion about this with you here on the board. I'm going to erase this. Hope you got it written down, or at least you can come back to it if you need to. Maxes and minimums. If you have an equation that starts out like this, just as an example, f of x equals, let's say, 1/2 x squared plus 2x minus 1. And let's say another one that is g of x, and it is negative 3 x squared plus 7x minus, let's say, plus 2. These are both in standard form that we just discussed. But the thing that's important about this discussion we're having right now is the sign on that front number called a. This graph right here, we can tell because of what a is. We can't tell where it's going to start from. Can't tell that. But we can tell that it's going to open upward and be kind of fat. So it's going to open like this. That's probably an exaggeration of the fatness. This one, because of the negative, is going to open downward and be rather skinny. But this discussion isn't about the transformation. It's about this positive or negative sign and what it does to the graph. This parabola, which opens upward, has its very, very bottom point right here at the vertex. Call it xy. That's where the vertex is. This one has its very biggest point at the vertex. Call this x1 or y1. This is x2, y2. I don't know where they are, but the maximum occurs here because this is negative. That means that the parabola has its maximum at its vertex, we say. This is a maximum. And this is a minimum. However, when they ask you to find the maximum or minimum value. Now, the reason I'm making a big deal out of this is because people always screw this up, so listen up. When they want you to find the maximum or minimum value, value means the y. How high up or down is it? Not how far out, right or left. How high up or down is the parabola? Which means you've got to find this. That thingy right there is the maximum value. Value. How high or low is it? This one right here is the minimum value. So when they ask you to find that, you've got to be looking for the y coordinate of the vertex to find a value. A value is always a y value, unless they tell you otherwise. Value always defaults to y. So with that in mind, I want you to look at example 3. And all it says is you have to decide whether it's a max or min, depending on whether it's positive or negative. In the a, the leading part of the function, it says find the minimum value or maximum value of f of x equals 1/2 x squared minus 2x minus 1. I'll go ahead and erase that so it doesn't look circled. The function is, again, 1/2 x squared minus 2x minus 1. Is it plus or minus? Dang it. Minus, minus. Okay. So here's our function. It's in standard form because we got an x squared term and an x term and a constant. And they want us to find the either maximum or minimum value. So let's decide on that first. Because this is positive, it's going to open upward, which means we're looking for a minimum. Because if it opens upward, the vertex is at the bottom. It's the minimum value. And what I have to do to figure out what the minimum value is to find the vertex. The first order of business for finding the vertex is to do negative b over 2a. Because that'll find the x coordinate. But that's not the answer. That'll just help us find the y coordinate. So I do negative b over 2a. Look up here. Remember, this means opposite. The opposite of b is 2. Twice a, which is a half, twice a half is 1. So the x coordinate is 2. We have not found the maximum or the minimum value. We've only found the x coordinate of the vertex. So now we have to plug it in. F of 2 equals 1/2 times 2 squared minus 2 times 2 minus 1. And I, again, recommend you grab a calculator to do this arithmetic, even though it's easy, so that when it's hard, you'll know how to handle it. So this is how I'm going to type it, so that you can see this up here. This is how I'm going to type that in. Just exactly like I've written it right there after the equal sign. So it's going to say 1/2. If you want, you can type 0.5. I'm going to write 1/2. So that's exactly like it is. So I start out with a parenthesis. 1 divided by 2, close it, x squared. No, not x squared. 2 squared. No, yeah, 2. Oh, dang. Okay. I'll start over. 1 divided by 2, close it. Then open another parenthesis to put the 2 in. 2, close it, squared. Minus 2, parenthesis. 2, close it. Minus 1. So your calculator is figuring out that value. It's negative 3. And so what we have here is that f of 2 equals negative 3. That, folks, that's the y value of your vertex. That's the minimum value. And how do they want us to report it? I'm not sure exactly, but that is the minimum value. Describe the domain and range of the function and where the function is increasing and decreasing. Oh boy, we got a lot more vocabulary to discuss here. But the minimum value, you can write this, min value equals negative 3. That's the y value that goes with it. And based on what we've learned here about this, just take a look at the graph for a moment. I'm going to go ahead and graph it on here since it's sitting right here in front of you. This is how you would graph in your calculator if you wanted to do it. You would type in 1/2 or 0.5. I'm going to use x squared minus 2x minus 1. Graph. Whoops. Standard screen. So I'm going to go to zoom down to standard so that it takes it back to a negative 10 to 10, negative 10 to 10, because the last thing I did was that fire hose problem. Okay, so that's your parabola right there. And I want to talk to you about certain vocabulary about it, because this is what it says to do. Describe the domain and range of the function. Domain means all the x's that work. And if you remember, this thing keeps getting wider and wider and wider forever, which means that every single x has got a y value to go with it somewhere. So the domain is all real numbers. The range is determined by this minimum value that we found, which is negative 3. nothing below -3 shows up. Everything starts at -3 and everything above that is shown because that's the y value or the minimum value of the function. So we would say those y's which are more than or equal to -3. That's the domain and range. We've talked about that before. And then this next one's kind of weird. It says places where it's increasing and decreasing. I'm going to put that right over here because I've run out of space down there. Increasing and decreasing. The function. I don't know what that means. I'm going to tell you and try to get this straight. Let's see how they want us to do it. In interval notation or what? Just a minute. Oh, okay. I see how they want us to do it. Okay. This function right here, whenever you're describing increasing and decreasing, you have to be moving to the right. So you have to ask yourself, if I was on this graph somewhere, say right here. Let's say I was right here and I was moving this direction, but I have to stay on the graph. As you move to the right, you are going down. In other words, you are decreasing. So from -infinity, way, 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 way out here, up to 2, you'll always be coming down or decreasing. From 2 on, this 2 right here that we found to be the x-coordinate of the vertex, from 2 on, if you're on this graph and moving right, you're going up. So we say that this graph that we just discovered, that's now about this. When it stops doing one thing, it starts doing another. Now we're talking about the x value of the vertex. It is increasing to the right of +2. And it is decreasing left. Get to the left of 2, you're going to be coming down as you move right. This is how we describe increasing and decreasing. So this function has a minimum value of -3. The domain is all real numbers, as it always is for parabolas. The range only works for -3 up, so y's which are greater than or equal to -3. And this particular graph is coming down to the left of 2, meaning decreasing, x equals 2. And it's increasing to the right of x. We probably should put this in there. X equals -2. We should probably put x equals so that we know we're talking about the x value of the vertex. Okay, that's how that one goes. Increasing and decreasing. You may want to review this. We have one more idea to discuss and a golf problem. So let me push this out of the way again. There is another form of a parabola that you're going to have to be aware of. And let me see what the book calls it. I may have a different name for it. Well, it's going to be called the x-intercept form, it looks like. So before I get to that, you may want to write this down because it's going to be really important for your study for the test on this chapter. We have what we've had so far. This is just a quick review. We have vertex form of a parabola. That's where you can read it easily for transformations. Looks like this. Where H and K are the vertex, and A will tell you whether it opens up or down, fat or skinny. We have standard form, which is f of x equals a x squared plus b x plus c. That's what we've been dealing with for the last 2 examples. And the vertex of that one is found by taking -b over 2a and then plugging it in. Get the y value, and then this a still tells you everything about it that you need to, up, down, fat, skinny. Then we have this other one called x-intercept form. That's the one we're going to discuss right now. And it looks like this. F of x equals a, the same a, that a, and that a, and that a right here in this new form gives you exactly the same information. Tells you whether it's going to open up or down depending on the sign, and whether it'll be fat or skinny depending on its size. But what follows it is this: x minus p, x minus q. And what the p and the q are, p are, let's see, the point on the graph, P, I'm not going to use that, P there. There are 2 points on the graph, and they hit the x-axis. They're called the x-intercepts. That's why we call it this. It's going to be the point P, 0, and Q, 0. If in this form right here, you can identify P and Q really easily. And this will give you 2 points on the graph of the parabola. Out of the millions that are on there, it'll give you 2 of them. But those 2 are really special, and they'll be able to give you other information so that you can find the vertex. And that's what you need to find. You need to have a way to find the vertex. Then A can tell the rest of the story. And the vertex, and I'll explain to you why it works out this way, but the vertex is, the x-coordinate is the average of P and Q, and then F of that average. You have to figure the x-coordinate and then plug it in just like you did with the other one. It's just done in a different way because of the way this is offered. Okay, so let's take an example and see if we can follow this information. A will still tell you everything else you need to know once you find the vertex. Okay, so I'm going to put the example over here. Hopefully you'll still have enough room to see. I'm going to put it over here and try to keep it within the screen here. Example 4 says graph -2 times x plus 3 times x minus 1. Okay, this is in x-intercept form because it follows with 2 sets of parentheses with stuff in it here. A, the size of it is 2, which means it's going, when we finally get done, it's going to be a bit of a stretch, and it's going to open downward, but I'm not ready to consider that yet. I need to find the vertex. So let me show you what's going on here. Oh, first of all, this value of P right here, P is actually -3, because look at the equation over here. This says x minus P. Whatever P is, whatever P is here, the opposite of it is written in the equation. So whatever you see here, see that's -P there, or opposite of P, this is positive P. So if positive 3 is in here, then -3 is P, and Q is 1, the opposite of -1. Those are places, those are these points right here. Those are places where this parabola, when we get done, hit the x-axis. So I'm going to plot those. P equals -3, here's the origin, is back 1, 2, 3. So I know one of my points on my parabola is right there. Q is at 1. It's going to open downward because of the -2. So just as an idea, just let me give you a gist of how this is going to be. It's going to be a parabola which opens downwards and hits these guys on the way through like this. Now, parabolas are symmetric, meaning if they hit this point here and this point here, then this point right here, this line right here, has got to be the axis of symmetry, right smack in between these two. Well, guess what right smack in between is? It's average. So to find the x-coordinate of the vertex, I've got to average P and Q. So I'm going to take -3 plus 1 divided by 2. That's -2 over 2, which is -1. So the x-coordinate of my vertex is -1 by averaging. Oh, you can't see that, sorry. Let me put it over here. Oh, can you see that? Oh, yeah, you can see that. Sorry. Okay, so the x-coordinate of the vertex is -1. How do I find the y-coordinate? Same way I always have, by plugging it in. So it would be f of -1 will be -2 times -1 plus 3 times -1 minus 1. Now, I'm pretty sure you could do that arithmetic, especially when it's something that simple. You can do your arithmetic in your head if you want, but it may get more complex as you go along, in which case you may want to figure it with your calculator. So I'm going to show you, again, how to type this thing in to figure this without you having to do any arithmetic. You go like this. -2, the negative sign 2, parenthesis, -1, plus 3, close it, open another one, -1, minus 1. That's replacing the x with -1 that we found it to be. Close the parenthesis, hit enter, there's your y value, 8. So the vertex is -1, 8. That's the important part. You have to know where to start. So we averaged P and Q, remembering the opposites of what you see in the equation because they got negatives on them. Average P and Q, plug that value in, kick out a Y value, and you now have the Y coordinate of your vertex. And that's really all you need because this tells the rest of the story. The -2 right there. So we come over here to the graph, and we use that information that we have now. We know where to start. We're going to start at -1, 8, -1, 1, 2, 3, 4, 5, 6, 7, 8. And we also know that it's going to hit at 1 and at -3. And by the way, when it's in vertex form, they want you to label all that junk. So we're going to have a point right here. Just put it near the point. It's going to be -3, 0. This will be 1, 0. You have to label those so that they know for sure that you found P and Q. Here's your vertex. Vertex is -1, 8. Put that on there. Draw your graph, just to show you that the count really actually does include these. If I count this, I would go, because remember that's -2, so I'm going to go out 1, not down 1, but 2. Out 1, not down 3, but 6. Oh, landed right on it. So this is your parabola, a little skinnier than the parent, as you can observe. And you're going to need also the axis. For this class or for this section, you're going to need to label the axis all the time. So we say axis, colon, x equals -1, the x coordinate of the vertex. So in number 4, it said, number 4, it says graph this function, label the x-intercepts, we did. Those are the ones with the zeros. Vertex, we did. And the axis of symmetry, we did. That's the complete graph. All from that information over there based on the x-intercept form. A still gave us the same information, but we had to use these numbers here in a different way to find the vertex. Okay. One last thing, and you probably want to get your eyes on this. This is example 5 on page 60. I'll get your eyeballs there. Page 60, 60. We're talking about some guy that's doing some golfing here. And remember we had, the other day we had the prom problem. We had one, they gave us one bit of information with a table and the other bit of information with an equation. Well, in this case, it's kind of like that, only they're going to give us one bit of information from one golf shot with a picture of a graph, and the other golf shot that we have to compare it to will be given to us as an equation. We got to see if we can make some decisions about which one's a better shot as far as height and distance across the ground and stuff like that. So we're going to be given the information in two different forms, and we've got to be able to interpret both of them to make a comparison. We've got to be able to see how they are alike and how to answer some questions. So take a look with me. On page 60, in example 5, it might be wise if you have your eyes there so you can see what's going on. It says, the parabola, that means this parabola to the left where that guy's taking a shot, you see the graph that they've got there. It says the parabola shows the path of your first golf shot, where x is the horizontal distance in yards, and y is the corresponding height in yards. The path of your second shot can be modeled by the function, and it gives it to you. So your first shot is this right here. This is the information that they give you. Something interesting to note. All of this stuff is in yards. Take a look at this vertex right here. I know you probably can't see that in my camera, but the vertex is 50, 25. And these are in yards, which means that the y value, 25, means the golf ball went up 25 yards at its peak of its path. Look at this guy. This is a really, really bad picture because that guy'd have to be 25 yards tall. That's ridiculous. Anyway, I just noticed that. I think that's weird and strange and funny. This one's a little bit better. That guy's a little bit tinier, but that's a dumb picture. Anyway, what we need to get out of this is that it went as far as 100 yards. It was shot 100 yards, and its maximum height was 25. Notice the 50 here. It's exactly half of 100 because parabolas are symmetric. So if it hit the ground, if it was on the ground at 0 and it hit the ground at 100, then at exactly 50, it was its maximum height of 25. So that's something to observe about that graph. So what we're supposed to compare is which shot traveled farther before hitting the ground and which one was higher. Well, this particular one with the graph, we can tell its distance across the ground and its height. So that's not hard. Now what we got to do is take this second shot and try to figure out its maximum height and its distance across the ground. And all they gave us was an equation. So now we have to use what we've learned here to try to interpret from this equation the stuff we need. It's negative 0.02x and x minus 80. That's our second shot, so I'll call it g of x. We don't get a picture of it. How can we use these numbers to figure out how far it went? Oh, look. That's very much like this. And you might look at that and say, it is not. Yeah, it is. This one right here, the reason why you don't see an x minus q is because if you add that in there like that, that doesn't really, well, yeah, that'll work. That means that with leaving this part off, the reason why it's left off is because when the guy shot the ball, he was at an x coordinate of 0, 0. So this is one of the x-intercepts that's not listed here. It's not necessary to list it because it's a 0. The other one, the other x-intercept, this is the p. That would be p equals 80. This was p equals 80, q equals 0. That's what we get from this one that's missing. That's the q right there. P's out here at 80. So this is another x-intercept when it comes up and hits the ground. That's where it is. And it's, so this is 80 right here. Now we know how far out this one went because it's the other x-intercept. Went from 0 up a ways and came down over here and hit the ground at 80. So your first shot went farther, but which one went higher? Well, here's the symmetry of parabolas that we got to realize. If it started at 0 and hit the ground again at 80, then somewhere right here in the middle, called 40, is where its vertex is. So the vertex up here somewhere has an x-coordinate of 40. What I want is this y-coordinate to see how high the shot went. How do I figure that out? Plug it in. G of 40, that x value right there, I want to know what the y value is that goes with this, is going to be negative 0.02 times 40 minus 80. And I grab my calculator. Pull this over here, like this. Grab the calculator and make it do this nasty grunt word calculation right here. So we grab a calculator, and we go negative 0.02, parenthesis, 40 minus 80, close it. I don't think it was 0.02, I think it was 0.2, just a minute. No, it was 0.02. Oh, I forgot something. Sorry, this is negative 0.02x, so I needed a 40 here as well. It came out to be 0.8, and that's not even close to the right height. It should have had an x here as well, which is 40, and then 40 minus 80. So I screwed that up. Sorry about that. There's another x plug-in we had to have, and I left it out, and that's the reason I got a bad answer. So I'm going to try this again. I'm going to say negative 0.02, parenthesis, 40, close it, open another one, 40 minus 80, close it, 32. So this value right here is 32. What happened was this ball went up, it reached a maximum of 32 yards at maximum height, and came back down here and hit it 80 yards out from the place it was shot from. So this one went up 32, whereas from the graph of the first one, you can see it went up 25. This second shot went higher, but the first shot went farther. That's how you have to use things to investigate. So this was actually in intercept form. It didn't look like it because it was missing another set of parentheses, but that's when you can assume that that value was 0. So you've got an x-intercept here and an x-intercept here. This tells you distance out. You have to plug that, or you have to plug the average of it, the middle part, in the 40 to find the maximum, because this is the x coordinate of the vertex. You plug it in here and do it properly. Make sure you put all the x's in as 40. You kick out a 32, tells you this one went up 32 yards, and you can compare it to the other one. So there you go. And for those of you doing it on paper, this is the assignment for section 2-2. 1 through 15 odd, 16 through 18, 21 to 31 odd, 32 to 34, 37, 38, 39 to 65 odd, and 69. And if you think that's a long assignment, you're absolutely right. That's horrible. It's 38 questions. Do your best to get through as many as possible and bring me your questions. I will be back tomorrow. We'll start moving together again after we get your questions answered. So good luck, happy calculating, and I won't be around to answer your questions until tomorrow, so do the very best you can. See ya.